If you look out at the night sky, you might see stars, but also there's planets moving around. By charting their paths across the sky, this is how we learned about Newton's law of gravity, and we can describe all the orbits using this one law of gravity. And we got all of this information simply by looking at how they move. I'm an experimental physicist. I run a research lab where we study all kinds of things that shape our natural world. Our world is full of all kinds of collective systems composed of many different objects moving and interacting together. Can we learn how these things are interacting simply by watching their motion? For this paper, the thing that we're interested in is plasma physics, and especially dust when it gets wrapped up inside of a plasma. When you put particles in a plasma, they interact, they're charged, except it's much more difficult than the high school physics we might learn about how charged particles interact because they're in a medium, they're in a fluid flow, and this fluid is a plasma, and it's flowing very fast, and it affects how they interact. So the main goal was to learn these complex forces that drive the particles around and make them do the things that they do.
I've always been interested in the social collective behavior in different animal systems. Justin showed up in my office and said, "Here is the data that we have. Doesn't it look like a swarm of flies?"
And so for this paper, I collaborated with my colleague, theoretical biophysicist, Dr. Ilya Nemenman.
And said, I can control plasma, I can control how many dust particles there are. It's much simpler than flies interacting with each other. If we can solve this, maybe you can later solve the animal collective behavior.
Professor Nemenman is an expert in AI, even though he's a theoretical biophysicist. And so we decided to try to throw AI at it and see if artificial intelligence could learn the physics about our dusty plasma in ways that couldn't be done without these tools. Over 99% of the universe is made up of plasma. On Earth, dusty plasmas exist naturally. They exist in wildfires. A lot of the soot particles are highly charged, and they can prevent the way that electromagnetic radiation can move in a wildfire. Let's say two people are trying to communicate over radio. That can be a big problem if there's charged particles in between the two radios. Dusty plasmas can be a big problem in the semiconductor manufacturing industry. When you're trying to make a computer processor, they often use plasmas to remove pieces of material or clean the wafer, and that if dust gets caught up in that plasma, then it's going to contaminate your sample. And our goal was to try to figure out exactly how they're interacting, forget all of the old theories, and start with something brand new. But our objects aren't alive, so one thing that I would love to see added is how much can we push this connection to living systems? That's one direction that we hope it moves to.
Conceptually, an animal is a particle in some large dimensional space. To me, the interesting stuff will be in trying to see if we can understand how animals or humans in a crowd, how do we interact with each other? Can I understand that there is mathematically measurable social force which either makes us attracted or repelled from each other? And so it becomes a very similar question to how do particles interact in three-dimensional physical state. So to me, it's the next step. We still need to figure out quite a lot of things along the way.
I think what's groundbreaking is that we were able to learn new physics with AI. Artificial intelligence can be a magnificent tool to advance scientific discovery if it's done collaboratively with the scientists involved. It can do things that we never thought was possible and learn such complexities and hidden things in the data that are truly amazing.